So here's an example of a GCSE question. It says rotate the trapezium by 45 degrees clockwise about -3, -2. So we've always got to remember three things when we rotate something. A, we need to make sure we have the centre of rotation. B, that we know whether it's clockwise or anti-clockwise. And C, that it's how many degrees it's travelling. In this case, 45. So the first thing I'm going to do is label our centre of rotation. So it's -3, so we're going to go -3 along the x and down 2 because it's -2, so our centre of rotation is there. Perfect. So the very first thing I'm going to do is draw on a line between one of the points that's easy to mark and my centre of rotation. So now what I'm going to do is measure 45 degrees from here to roughly here. So I'm just going to try again with this and see if it works. So clockwise, 45 degrees, and it doesn't like me, that's a shame. So let's try it a different way. Give me 2 seconds. Okay, so I've measured 45 degrees by putting my crosshairs on my centre of enlargement, which is here, and then putting my 0 down the line of the protractor and measuring 45 degrees. And then what I'm going to do is create a ray line. Now a ray line just starts at one point and continues forever past that point. So now I know that from this line, I'm just going to move this point up a bit. Can I? No, it's going to stay there. Okay, that's fine. Let's hide it. Now what I'm going to do is I'm going to measure the distance between here and here. So let's measure it. I'm looking. Okay. So I'm going to measure between here and here, which is 5.83, and then I'm going to measure a line of 5.83 from here to here. So we want a line with a given length. What's that? 5.83. Okay. So now I should be able to move this to meet my line, and I know that point there is going to be, when I line it up properly, there we go, that point there is going to be my image of C, so I'm going to label it. And the key thing to do with these is to label them. So I know that that is the image of C, this point here. Okay. Now, really nicely, because C is on the same line as this point, which is called B, that B is going to be a certain distance away from E as well, but on the same line. So E is going to end up being here somewhere. So let's do the same thing. Let's measure the distance between here and here, and that's 10.3. So it's starting to get a bit clustered here, so I'm just going to move these to one side slightly so it's easier to see. Now what I'm going to do is measure 10.3 again, and that's going to be my E. Sorry, it's been a little while since I've used this system. Come on. There we go. So E is now going to sit here, so we can label that now. So straight away I've actually got 2 of my points, which is really nice. So now what I can do is, I know that this is perpendicular to here, so I'm going to create a perpendicular line that goes through E, and I know, if I just pull my screen down a little bit so you can see it better, I'm just going to move this as well out of the way, it's getting a bit claustrophobic. Okay, I know now that because that wasn't B, was it? Sorry, that's my fault, I've labelled it incorrectly. Should have been B, sorry people. Okay, so I know that B and C are already done, but I know that A, because we have a trapezia, okay, and this is a 90-degree angle, okay, you can double check it if you want. Let's see if we can work that out. No, angle. So let's see. So if it's 270 degrees here, that means it's 90 on the inside. So now I know that if I draw a right angled line here, okay, I can measure the distance between here and here, and that is 2.24, and then my A will be 2.24 centimetres up from B, because that's the same as it is here. So again, let's measure a line with 2.24 and slot it to my grid, and that is where my A is. So let's write image A, so it's A dash, or A apostrophe technically. So now I've got 3 of my points. I really only need to work out my last one. So let's use the same system again. So I'm going to draw a line. I'm just going to hide some of this so it makes it easier to see. Okay. Oops, wrong object. Okay, keep going. Okay, so far we've got these 3 points, so let's put those together and line them up. Okay, and now we need to work out D, or the image of D. So we're going to do exactly the same thing again. Instead of using this line, we're going to create an object from E to D. So let's make a line from E to D. That was silly. From E to D. And now I'm going to measure an angle of 45 degrees from E give me a second, it's been a while since I've used this system. So we're going to create a line from here, and we're going to measure an angle with a given size from E, and we need, come on, please work. Yeah, so it's 45 degrees clockwise. Oh, what a shame, it's not worked. Okay, give me 2 seconds. Okay, so I've got my 45-degree angle, and that means that I can create a new ray line between here and here. Oops. So now the distance that I've measured should be between, between D and E, which is 8.49. So technically my D point should be 8.49 away from there. So let's do 8.49 from here. And then if we drag it, that should be where D is. So essentially what I've done here is I've measured 8.49, the distance between D and E, and then I've measured from here to here. So the same distance along my line that's 45 degrees away from my centre of enlargement. Now that should be my point D. So now I've got all of the points I need, I just have to join them up to make my object. So D to A, D image C, and there we go. I have actually got my shape that's been rotated by 45 degrees. Job done.